talk. One of the most technical and the most critical infrastructure today that most of the nations are trying to protect is the telecom industry. And since we are rolling out the 5G infrastructure for various nations globally, innovation comes with its own challenges and weaknesses. So let's find out more on the telecom security challenges for 5G network via the founder of Matrix Shell Technologies, Akib Sayyed. Akib, over to you.
Thank you, Antriksh. Let me just share my screen. Okay, guys. Can you see my screen, guys?
Yes, it's visible.
Okay, good. So thank you, Antriksh, for the introduction. So I'll be talking about the security challenges in 5G. Okay, as we are moving towards the 5G, India is gearing up for the 5G technology. There are certain challenges that we need to look at when it comes to the security part. But first, I'll tell you about me. I'm working in telecom security since last 8 years. My first talk was in Nullcon, and I really appreciate that Nullcon gave me a good platform without having any initial experience in security. I thank you, Asim. I thank you, Antriksh, and the rest of the Nullcon team. So I am a GSMA member. I mean, my company is a GSMA member, so I am actually contributing to the fraud and security group as well. I'm founder of Matrix Shell. We are doing the telecom security research all the time, and yes, we are hiring whenever we require some more strength. Anyways, let's go ahead. What I do for the telecom operator, I do all the telecom audit when it comes to any technology like 2G, 3G, 4G, 5G, as well as penetration testing of the voice over LTE, fixed IMS, or it could be air interface. And we used to do some tech testing for the telecom operator, which is manually. Now we've automated our SS7 diameter and GRX penetration testing. We also do the telecom forensic for the telecom network. Let's leave that part now and let's get into the 5G now. So what exactly is a 5G that interests us is most of the time is speed. We started with 2G speed, then we had 2.5, 2.75, then 3G, then ahead 4G, now we have the 5G. So 5G is claiming to be going up to 20 Mbps speed, which is 10 to 100x faster than what we get in the 4G. Okay, we also have the low latency network. Okay, when I say talk about the low latency means I think technology people do understand this point about the latency, but the 5G is claiming to give 1 millisecond latency when it reaches to the core and goes back, returns back from the core. It also claims to give up to 10-year battery life for the low power IoT device using like a narrowband IoT or CAT-M devices. Also, the 5G can replace the traditional wired broadband like I'm not saying about the fiber broadband, but I'm talking about the wireless broadband wherever there is not less possibility or less difficulties to get the fiber laid out. The mission critical communication is also a good part of the 5G because 5G is supporting multiple technologies like push to talk, instant push to talk services, or some more. There are more details into that. We are not looking at this right now. 5G also claims to be as 4G claim for the V2X, vehicle to everything. 5G also giving the immersive entertainment like virtual reality, augmented reality, as there is a less latency and the higher speed. So what is the 5G and why 5G from security point of view? 5G establishes end-to-end trust when it comes to authentication, integrity, and confidentiality. You might say that these points are already there in 4G, but why we need them in a 5G again? So there are some issues in the 4G that actually gives out the initial information like your MC when you're transmitting or you're trying to connect to the network after switching on your phone. So 5G also prevents that by doing the encryption and then only revealing the identity after the authentication is verified by the telecom network, which is the home telecom network. Also, 5G removes all the assumptions when it comes to safety from product or process. Means in 2G and 3G and 4G, we saw that, okay, we are relying on the product or we are relying on the certain process to have a security, okay? But 5G removes this part and 5G is contained with the security. I mean, we can say that 5G is like secure by design, but still there are some issues still exist. Now, mandatory encryption is there for inter-traffic or the intra-traffic. What I mean by the inter-traffic means it between the inter-traffic and intra-traffic means by the all the interfaces in the 5G are encrypted. Whether it is a core communication, whether it is some other communications like between the operators, between the operators inside the country. Yes, they have the mandatory encryption for the same. 5G improves the confidentiality and the integrity of data, as well as there is a home control authentication. Now, some of the issues which has come to the 2G, 3G, and 4G is the visiting network decides whether the authentication is completed or not. This is improved, but this is a lack issue in the 2G, 3G, 4G. But in 5G, the home network decides whether the authentication is completed or not. Also, 5G has a integrated roaming protection called security edge proxy protection. This protection gives the full roaming security if yes, of course, if implemented properly. Yes. Now, how 5G is better than 4G? First thing is that encrypted user identity over the air. So whenever there is a non-encrypted communication that is happening when you switch off the cell phone, so 5G uses a SUPI. It should be sushi, not supi, not the permanent identifier. It should be sushi. So it's a concealed identifier. Okay. So also there is a home controlled authentication check. Means the home network can check if the particular cell phone who is requesting the 5G service is actually roaming there. So 5G does say like does verify like that. There's a SEPP, security edge proxy protection, is like an edge firewall which legacy technology fails to provide. There's a network exposure function which is integrated into the 5G network, that is giving the third-party API into the third-party API to the integration of the third-party app. What do you mean by that? So let's take an example. If you are using SS7 or if you're using a diameter, you need to integrate this all your services inside the specific protocol. So if you want to have any external function for some banking application, whether it is based on the USSD, whether it is based on the location, whether it is based on some other stuff, so you have to integrate the entire network or the entire stack of the protocol inside the operator's network. And it becomes difficult for the operator to actually control it. They can implement the firewall, they can implement some other thing, but 5G exposes the certain function which is required for the third party application to function. Yes, there is a NEF function is there in the 5G. Now, improved AKA authentication key agreement for the protection of the initial NAS messages. Now, as I said in previously, like wherever you switch on the cell phone in legacy technology, your MC goes over the air unprotected. So whatever your plain text IMSI, it goes over the air directly. But 5G came up with something called the SUPI, which is a private identity. But when it goes over the air, it is encrypted by the cell phone and then sent over the air with encryption. And when this reaches to the core network, when it reaches to the core network will then authenticate it. If after the authentication is completed, then only the the private identity is exposed to the AMF, that is mobility function. But one thing here is that the home network always verify whether the authentication is successful or not. 5G also claims that they are going to implement the 256-bit encryption for 256-bit encryption and integrity of the user data. That is actually proposed. That is not yet finalized. So what are the 5G modes of deployment? There is a NSA mode, there is a SA mode. When I speak about the NSA mode, it is non-standalone. It means 5G network has to rely on some other network, let's say 4G network only, to provide the 5G services. Means the tower of the telecom network that belongs to 5G, another tower of the telecom network that belongs to 4G. First, phone will be latching onto the 4G network. Then the data traffic of the will be sent to the 5G tower, and it always relies on the 4G control point. There are multiple different modes as well in the NSA, but we are not discussing those as of now. There's a standalone which uses the 5G cells and the 5G core for the signaling and the data. So let's look at how exactly the NSA looked like. If you can see here, let me just take a pointer. There's a pointer. Yeah, that is. So this is the NR, like a new, in 5G. Yeah, I forgot to mention that the 5G has a new name, that is 5G NR, new radio. So if you see this red color is a 5G tower, and this is the gray color. It is the old LTE tower, and the gray color EPC, Evolved Packet Core, is the old EPC of the 4G. Now, if you see about this thing, the dotted line is just a control plane, okay? And whenever you switch on your phone, you go to the LTE network, you go to register over the EPC, and then EPC will be sending that, okay, there is a 5G network in NSA mode available in your area. You should send your data through the 5G network so that we can you can get the 5G services. Now, one of the operator in India recently tested this in Hyderabad. I will not name this because I don't want to get into any conflicts. So they tested the whatever the mode they tested, that is the NSA deployment. So initially, all the operators are going with the NSA deployment because EPC, that is a 4G core, is already there, and they don't want to again invest into it easily because 5G SA comes with another cost. But still, let's look at the how 5G SA looks like. So we have completely different network here. We have 5G core, we have EPC. They can communicate in between them just for the any handover or a downgrade purpose. Also, they have the complete different LTE network, complete different new radio network, and all the signaling, that is dotted line, and that complete line, the single line or straight line, that is the data which is go through the core network. And if there is a necessity of the EPC and the 5G communication or in terms of data or signaling, yes, that happens between the code directly. No need to involve the BTS. Okay. Okay, so let's go to the high level components of the 5G. Actually, I wanted to keep this talk more on the technical, but as people are not much aware of how the 5G is, what it is, so I'm limiting this to very high level components. So we have the radio access network, which is called the new radio. We have the MEC, that is multi-access edge computing. We have the 5G core, that is the 5G core handling all the traffic. We have the roaming, that is SA roaming, there is non-SA roaming. Now, when you speak about the SA roaming, that is SA network to SA network roaming. When there is NSA roaming, there is NSA to NSA roaming. Next thing, security challenges in the 5G. Let's start with the radio access network. So, increased bandwidth increases the protocol complexity. Yes, exactly the point. So this allows the room for the implementation vulnerability as well as the configuration vulnerability. If you see the previous technologies, that is 2G, 3G, and 4G, you must have seen the SS7. There is no way to perform have an encryption. There is no way to perform the authentication. There is no way to perform the check the integrity of the data or confidentiality of the data. But when it comes to the 4G, yes, they have implemented all these things, but this actually allows the implementation vulnerability, like the one which we discovered after fuzzing. So those vulnerabilities are still there, and it is a good chance for the researchers to start with the fuzzing the radio network, whether it is a cell phone or whether it is a tower. Yes, that is a good chance there. There's a signaling drag. Now, what I mean by signaling drag is, see, to communicate with any network, you need to perform initial signaling for that. So whether it is a 2G, 3G, 4G signaling, it has to be there when it comes to the implementation of the 5G. Nobody can go like say that, okay, from today onwards, only going to use the 5G SA network in the country. But if he wants to actually give this functionality in the country, okay, khalas, he can give it, no issue. But when the subscriber of the 5G SA goes to the other country, he might get the NSA, he might get the 2G, he might get the 3G. So 2G, 3G signaling drag is still there that allows the older vulnerabilities to exist in the network. There is a roaming interconnect issues. Roaming interconnect mandate MNO to support the legacy protocol for the roaming. The same part that is actually dragging the signaling part here. We have the zombie UE problem. What I mean by zombie UE is, let's take an example. We are in the area in the area that is actually about the mobile malwares. So just imagine a case that somehow your phone or either from your browser or from the malicious app, your browser or phone your phone goes compromised, and if he is sending a DOS attack towards other subscriber or the network, imagine the issue that can cause. So we will look into that, what exactly the zombie UE can do. It's just a basic test use case here. We have the edge computing. Now, what do you mean by edge computing is, let's take an example. We have Mumbai. In Mumbai, we have a dock, that is a shipyard. Okay, so there is a huge transport of the containers and everything. So 5G gives one advantage for these people to have their own local private 5G there. Okay, now, just to have a local breakout or the faster breakout, so 5G implements the MEC, that is multi-access edge computing. So this allows you to have the local network and the faster communication. So as we see in the 5G, we have one point, that is the network function virtualization. So they are using virtualization, they are using some other techniques. Okay, it could be the VMware based or a container based. So all the issues that is applying to the open source or the container security threats, that applies to it. As well as 5G is moving more towards the IT rather than the traditional telecom protocol, because first initially 2G was most of the ASN1, 3G, yes, that was 2, but 4G, when it comes to signaling, it moved little bit from radius to diameter, which is from traditional telephony to the normal IT. But now the 5G comes with the HTTP2 protocol with the JSON interface. So there is a good chance for the web application developer to get into it, to learn about it. Also, the configuration issue still applies if the weak configuration is there, and more interfaces and more open source code is going to be there, unless there is some uh, test cases validation, or the fuzzing is there. There will be some issues that will be applying. Let's take example, we have the Kubernetes, or we have the containers, or we have the Dockers. So if some issue applies to that, yes, it is going to apply to the same instance which is using that version of the Docker, or anything. So IT too has defined the threat landscape for the 5G. So there are multiple parts of it, like like illegal intercept, DOS attack, flash traffic, which is actually the DOS, then the privacy breach, fake BTS, slicing or resource threat, that is actually coming into the NFV part. Then we have the threats originating from the internet, someone who's trying to attack inside or to the subscriber. Then there is a security policy conflicts. So there are multiple threats that those are there, that's ITU had defined. Let's look at what are the key areas that can cause the security weakness in the 5G. So if you see about the 5G, we have the cloud-based architecture that can cause a problem, network function virtualization, software driven operations. Then we have the software defined network. We have the data security at the edge, and the RAN and the zombie UI. Let's look at them one by one. So cloud-based architecture, completely based on sharing the hardware resource. Like let's take example, you have one where you have multiple options. Either you have the infrastructure as a service or a platform as a service. So the owner of the platform is going to share the hardware resources between the different users, or different containers, or different virtual machines. So if there is a hardware limitation, or if there is a hardware problem, that is going to cause your MEC to collapse. Also, if the host is having some vulnerability, that can cause a problem. Yes, that is going to affect the internal network elements as well. Privilege escalation is a major issue, but if we can prevent the privilege escalation, that could be either on the specific container or virtual machine or any virtual instance. We also have the session flooding issue in that. Risk of the open source in the 5G, like I said already, right? If there is anything that is affecting the Linux kernel, it affects everything that who is using that kernel. Same way, if there is some issue in any version of the Docker, the EPC, the core network is using, yes, that is going to affect them as well. So it could be a open source software, it could be open source library, it could be open source protocol stack, or it could be a custom protocol stack as well. So recently there was some research that is done by some organization. They were claiming that the TCP/IP stack was having a huge issue of the buffer overflow that was causing the issue in the IoT devices. So those issues, if the stack is the vulnerable, so anyone who's using the stack is going to be vulnerable. Software driven approach our operations. Okay, so everybody right now is mostly going on the like automated automation. So and gate of trust is properly needed to implement the properly the automation in that. Sufficient auditing has to be there to prevent any issue in the automation part. We have the orchestration, we have the shared control between the system users, that is going to cause a problem. Lack of the supports and updates and the secure communication. Now let's take an example. We have one virtual machine and there is a host of the virtual machine. So if we are not updating, and if let me give you one example of the telecom, it is not like we got an update and we installed it. First, the lab is update is implemented in lab. It is tested thoroughly whether it is affecting anything, whether it is doing anything. By the time we actually implement the patch or the new update, it is going to take at least 3 to 4 months minimum, I'm talking about. Also, AI ML is still difficult to implement in the telecom because it's often black box and it is learned and trained on the database. AI based decision will take time to mature because in telecom there are very uncertainty. Because let's take example, if you are using AI on certain path or certain things, okay, so let's take example, we are using AI on the certain data set of the business application. So you have certain criteria as defined. But if you talk about the telecom, subscriber could do anything. Anything means anything. He could browse it, it could do it, it could be any use case. So it will take much. So AI or ML based decision will take time to mature if you are implementing AI ML in the using in the software driven operations. We have the NFV, that is network function virtualization. Management and orchestration of the NFV security could be an issue as of now. Then the resource isolation and securing the traffic. Now we have seen, as the people who are experienced with the Docker, they will be able to easily tell what is the why there is a need of a virtual firewall, IDS or IPS. Because let's take an example, the containers or the Docker, they implement they implement their own internal network. Okay, so like a software defined switch they implement. So if we need to do some port filtering, if we need to do some IDS implementation or IPS implementation, we have to be part of that particular software, like a software firewall, or it has to be there. We also need to block the unused unnecessary port. That is a standard practice actually. When it comes to software centric security, secure against the common software vulnerabilities has to be there, and there has to be a thoroughly testing, like fuzzing has to be there. Now we need to do the NFV monitoring. That is, it could be software defined network or virtual monitoring. We also need to do the virtual sockets monitoring, that is between the different virtual machines, as well as the health monitoring. Attestation of the hardware or the software component. Why it is needed? Because let's take example. I'll give you one example. There is buzz in the deep web, that is there is a SS7 malware. What this SS7 malware does is it patches the kernel, and after patching the kernel, it sits between the SCTP protocol area, and it just monitors everything in between, and if necessary it modifies it. So there is a need of maintaining the integrity of the software component. By it could be a digital signature based, or it could be some other means as well, but digital signature based, that is necessary. Then we need to do the software defined network security. Why? Because we need to maintain this complete SDN controller in an isolated environment. Okay, like I mean, yes, it is not completely practical, but we need to implement those. Excuse. We need to implement the API or protocol level security. We need to protect the route between if it is a virtual route, or is it a if it is a physical route, on it could be on virtual interface or in the physical interfaces as well. Data security at the edge network. Now as we seen that, we seen the example, I gave the example of the Mumbai dockyard. Okay, so first thing is that if we are implementing any edge computing, then we need a physical security, we need a necessary alarms implemented at that place, we need a regular security audit of that place. Also, there shouldn't be any credential caching on the MEC side. Now edge computing framework for the orchestration and the business logic has to be audited whenever necessary, and it has to be done on the regular basis. We have multiple issues as of now when it comes to the radio. It could be jamming, spoofing of the network, interception of the traffic, or redirection. Now, how this could be happening? Now, let's take an example. If you're jamming the network, how do you identify, or if you're spoofing the network, how do we identify? In a cell phone, there is an option called as a measurement report. Actually, this happens in background, like a neighboring cell measurement report, or you can monitor the sudden drop in the signaling from specific area. Okay, then you can investigate into this. There could be a check of the downlink and uplink jamming by identifying the parameters in the network, or by the G node B or E node B itself if it is an NSA mode. Then we have to physically secure the site from the physical intrusion. Also, there has to be a validation. If someone is spoofing the network, how we can do this is, let's take an example. I'm running XYZ networks impersonating PQR network. Okay, I'm impersonating them, and the phones nearby are trying to connect to me. So what initially the frequently the network MNO could do is they can ask for the neighboring site measurement from the UE, and they can identify which belongs to them, which doesn't belong to them. Also, there is technically speaking, there is always a room for the spoofing, but still this is the minimum that can be done. Also, there has to be implementation of the end-to-end security between the RAN and core. There are multiple halls here, like mid hall, front hall, back hall. Those security has to be implemented here. Now, coming to zombie UE, infected for phone causing DOS. Okay, you must have seen the movie that is Mummy. In that Imhotep says, "Okay, do this, do that, blah 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 blah." Same. Let's look at the one case, the use case. One smartphone with a 5G connectivity generated 30 Mbps of DOS on a website. Imagine what this 1,000 smartphone could do. It could generate a 30 Mbps, 30 Gbps, and imagine 10,000 smartphones generating a 300 Gbps of DOS on the website. Now we've seen in India, we've seen one thing that the internet penetration is big and it's huge when the Geo came as a player. And what we are seeing right now is anybody with a smartphone is going for, it could be video doing the TikTok or TikTok alternative, YouTube. Everybody is behind it. For that purpose, the main reason of the youth joining the TikTok and joining the videos is a monetary gain. So there could be some as this monetary gains expectation goes higher. So what we can expect from them is, we can expect them from is their we can give the chance to the this opens a chance to the actually the fraudster or who wants to commit such a crime. Okay, so that gives them an opportunity to, send the phishing mails or send a spoofed application or some like a application that can promise the user that some money, so that can cause opening there. So we need to also implement the AI based, artificial intelligence based traffic shaping, because it is a huge data. Imagine, even if in India we are able to give one cell phone a Gbps speed, that is a huge speed for us, for someone to handle that. So we need to do AI based traffic shaping for this GSM, for the network that is going to be there. So requirement of testing in 5G. So I've defined there are multiple interfaces. We have 5G air interface, which could have the 5G handset, wireless 5G test nodes could be there. So we need to do the air interface assessment. We have the MEC, mobile edge computing platform, sorry, multi-access edge computing platform. We need to do the testing of the MEC and the backhaul. Then we have the core network. We need to do the complete core network testing. Now, as we've seen that in the 5G, we have the protocol called HTTP2 and the JSON-based APIs. So that opens up the web application developers or web application security testers a good area to go and explore into it. One of my friends said that, I know what is up with the people who design the 5G, that they want to bring in more IT companies rather than the telecom companies. So he was saying that there is something happening in the background. Okay, let's leave that. I'm like, let's secure it. Let's focus on securing it. Now there is one more remaining interface, that is roaming testing. You need to do the continuous roaming testing to test your 5G or the legacy technologies readiness for that. Next, we have what we can do in the air interface testing. There could be configuration testing. There could be non-access stratum protocol testing. We can do a DDoS simulation. We can also check the NFV or the container burst. When the actually NFV and container burst is the orchestration failure when assigning tasks to the new container, or popping up and pushing down the new container as required. We need to do the G node B testing. It could be configuration assessment, physical attacks on the hardware, because the 5G claiming to be the huge number of G node B is going to be implemented. We need to do the RRU and the Open RAN testing as well, like the remote radio head and Open RAN testing has to be there. We need to do the MEC backhaul thread testing. When it comes to MEC platform audit, it could be platform as a service, infrastructure as a service, slicing validation, traffic segregation has to be there. When it comes to front haul, mid haul, and black haul testing, we need to do the network architecture audit, configuration review, traffic analysis, and the attack. When you speak about the traffic analysis, we should include operation and maintenance, user data, and the signaling as well. Now, there's one more nice part for the web application developers or web application testers, that the MEC application exposes the web API to the third party. Also, when it comes to NFV, if the MEC and NFV burst testing, yes, we need to do the DDoS simulation to test what can go wrong in the burst NFV part. We have to do the 5G core testing, that is analysis of the deployment architecture, how do we also, we need to do the different file slicing validation. We need to do the signaling protocol assessment, okay, whether it is a HTTP2 or JSON based, whether it is a PFCP protocol, or whether it is a DOS attack. We need to simulate as an internal attacker. It could be on a VM virtual machine or a Docker. We need to try for the privilege escalation. We need to try for the some distro-specific vulnerabilities. Of course, distro-specific vulnerabilities could be distro-specific vulnerabilities, like those could be like just like distro-specific vulnerabilities could be like there has to be found out of the fuzzing. We need to also do the DDoS simulation from the core network. Impersonation or the data interception has to be there. Like PFCP is vulnerable for the session modification attacks. Next thing is that roaming and internet testing. We need to do the SS7 testing just to be actually SS7 doesn't actually relies for the part of the SS7 and diameter actually doesn't rely for the SA or an SA mode. But the thing is that to be compatible with the legacy technologies, when the subscriber of the 5G network goes outside of the country and roam in another country, so for that purpose we need to do the SS7 and diameter testing. GTP testing has to be done as well as, and we need to do the internet testing as well. Coming back to the technical details of the testing, yeah, air interface, multiple things are there. Configuration vulnerability, physical side intrusion, NAS protocol vulnerabilities, DDoS simulation, or the SCAS validation has to be tested. As we have the short time, I need to quickly go through them. No issue. We have to do the MSE and the backhaul threat testing, analysis of the different models of the MSE. It could be PASS, IPASS, IaaS, okay. Now then slicing validation, like I explained this everything to you guys in the previous slide, but I'm still explaining them. One is a network architecture audit, configuration review, traffic analysis has to be done based on the AI based, as well as the DDoS simulation has to be there. We need to test the web application as well as the web API in that. When it comes to NSA core and its testing, then we have to do test the EPC and the RAN in addition of the with addition of the Gnode B. We need to see how what signaling drag is affecting my network, whether it is going falling back to 2G, 3G, whether because as of now enough there is a voice over NR is there, but still the in the NSA mode the operator are still going for the voice over LTE based NR. So okay, and if there is no voltage there, then from 4G to 2G, 3G, you have to come back. Actually, one of the operators already switched off the 3G network from India, from the pan India. So they are using 2G if there is no voltage capability available in the phone. So from the user comes from the 4G to 2G network and then performs the call there if there is no voltage capability. Then we need to identify the different path for the route looking or core network exposure in the user plane. We need to see what are if the slicing validation is properly done or not. Coming to the SA core, we need to check most of the thing. Like initially, first we need to check what are the risks of open source thing. We need to check the lack of code signing. We need to check what are the different threats for the 5G that is affecting the HTTP and the JSON API. That could be header manipulation, session hijacking, malform traffic generation, protection mechanism bypass. It could be like a PFCP protocol testing. I will be explaining what is SCAS in the last slide. So we need to do the roaming testing, as I said earlier, like SS7 diameter, GTP, and the 5G SCPP testing has to be there. Yes, the 5G claims that we have the SCPP, but yet there are still some vulnerabilities that could be affecting him. We need to test that as well. So GSMA has come up with a nice initiative for the telecom industry that is called the NSAS, that is Network Equipment Security Assurance Scheme. It is defined on the compliance check based on the 3GPP document. It is called the SCAS. Okay, this SCAS document, they define what testing has to be done for the certain network element if it has to be deployed in the network. So there are multiple vendors who are already participating in this. There is Nokia, Ericsson, ZTE, Huawei. Actually, I'm expecting the India is the part of the India that is most of the telecom stack that are being developed in India. Like if you speak about go to the internet and search for the protocol stack development, most of the companies in India that are developing the protocol stack, so they need to participate in this testing, so that they can check their complete network, they can check their complete strength of the network, that they can check the strength of their devices. Because what I've seen that is most of the Indian vendors, they are just developing the stack and they're selling it to the European companies or any other companies who are interested in buying the stack, saying that we can give you the stack, but we cannot sign the SLA. But if you implement the NSAS and some more testing, yes, Indian stack vendors or the protocol vendors can say that yes, we can sign the SLA, because we've seen that the stack vendors or the network equipment vendor, they say that no, we cannot sign the SLA. That was the case with one of the operator. No issue. So thank you guys. Thank you for your attention. If you want to contact me, you can contact me at as@metricshell.com. Also, we are going to start one free webinar series on certain topics of the telecom. You can check this link and submit your interest for this. So as of now, if you have any questions, just let me know. I will be happy to answer them. Please.
Thank you, Akib. I'm sure the telecom industry needs more assistance and audits when it comes to 5G networks. We have few questions, Akib. I'm going to read them out for you.
Yes, please.
Uh, at what layer does 5G implement encryption to protect voice data?
So as of now, nobody is implementing the voice over NR, but it is still there in the specification. So whenever you are talking about the encryption, there are multiple encryption that are happening. That is, first one is over the non-access datum detail. That is a signaling protocol. There is a access datum protocol. So if you're talking about the non-access datum, it is encrypted end to end. Means if it is going from your cell phone, it is going till the core and then it is decrypted. But if it is if you want to do a data, that is your user traffic, that is encrypted from your cell phone, and that is goes to the till your tower.
All right.
Yeah.
There's another question. Aren't there any interface management mechanism like ZC sequence or something?
As of now, I'm not aware of it, because even we are studying the 5G. We started our internal research like 3 to 4 months ago, and we are able to find out some vulnerabilities in the PFCP as well as in the air interface. But that is still, our study is still going on as of now.
All right. I'll take the last question before we open for break. Required hardware list for testing 5G network, like SDR frequency range
Okay.
support.
Actually, if you see USRP B210 SDR can be used in the NSA mode, but you'll need two USRP B210 with stable clock. I will say that they have the special clock, like a tiny device, but it costs $700 for that. You'll need two devices of that, and you will need extreme edition of the i9 processor to set up your own 5G network, whether it is NSA or SA. But approximately, I'll say that that budget is going to be around $6,000 to $7,000. Rest
All
is
right.
that if you want to test the open source version of it, you have free 5GC and RAN simulator, where you can actually simulate the actual 5G traffic in SA or NSA mode. Yes, that people can implement it on open source. But if you want to actually run your cell phone on the 5G network in SA or NSA mode, yes, you need at least 7,000 to 8,000, 6,000 to 8,000 budget for that.
All right. Thank you, Akib, for this amazing presentation. We look forward on your upcoming webinars and learning more about telecom security.
Thank you, Antaresh. Thanks for everything.
Thanks.